Welcome to the Chapter 2 test review for Honors Geometry. So in this video, we're going to go through the answer key and I'll give you some things to consider or explanations of how I arrived at the correct answers. So number 1 asks us to match the term with the most appropriate drawing. So part A, a non-convex hexagon. So we're looking for first a non-convex figure, and then hexagon meaning 6 sides. So I know my only options for non-convex would be figure 1 or figure 3. 2 and 4 are both convex. And then if I count the number of sides, figure 1 has 6 sides, so figure 1 is our non-convex hexagon. In B, we have a convex pentagon, so 5 sides and convex. So we're looking at 2 and 4. 2 has 5 sides, so 2 is our convex pentagon. In 2, it says, use the definition of a polygon to explain why the figure at the right is not a polygon. And the problem here is we see this gap. So how do we explain that using the definition of a polygon? The issue is that not every segment is intersecting 2 other segments at their endpoints. In 3, it says, consider the following definition of midpoint. The point M is the midpoint of segment AB if AM equals MB. Which property of a good definition does it violate? It doesn't completely describe what is being defined because it doesn't say that M is on segment AB. In 4, underline the antecedent once and the consequent twice. So it reads, if it rains when the sun is out, there will be a rainbow. So what they did is they just cut out the word then, but we can assume it goes right here after the comma. So if it rains when the sun's out, it rains when the sun's out is our antecedent. And then our consequent, the conclusion, would be there will be a rainbow. In 5, let M be the statement ABCD is a quadrilateral, and N be the statement ABCD is a polygon with 4 sides. Write the biconditional for M and N. This symbol here with the double arrows is our biconditional, meaning it's an if and only if statement. So we could write that as ABCD is a quadrilateral if and only if ABCD is a polygon with 4 sides. And then in 6, there's multiple options for your examples. In 6a, an instance of the conditional would be a value for x and y that makes this conditional statement true for both parts. So if x is less than 11, then x times y is less than 11 times y. So one instance, we could have x equals 2 and y equals 3, which makes both parts of this conditional true. In B, a counterexample would be something that makes the first part true, but the second part not true. So if x is less than 11 and y is 0, that would make this not true. So if I chose any number for x less than 11 and y was a 0, that would make this not true because x times y is 0. 11 times y is 0. 0 is not less than 0. 0 would equal 0. Or you could use the example of x being any negative number and y being any positive number greater than 0, and that would also be a counterexample to this conditional. In 7 and 8, they want us to consider the conditional statement. If a number is divisible by 3, then it is divisible by 9. So in A, it says give an instance of the conditional. The number 27 is an instance of the conditional because it's divisible by 3, and then it's divisible by 9. So you could choose various answers as long as they're divisible by 3 and divisible by 9. B, is the conditional true or false? If false, give a counterexample. It's false because of numbers like 6 or 12. They can be divided by 3, but not divisible by 9. And divisible in this sense means can be divided by giving us a whole number, not a decimal. In 8a, write the converse of the conditional statement up here. So we're flipping our antecedent and consequent. So it would read, if a number is divisible by 9, then it is divisible by 3. And in this case, that is true for all instances because anything divisible by 9, by definition, is also divisible by 3 because 3 is a factor of 9. 9 says, rewrite the following statement as a conditional. Equilateral triangles are always isosceles. So we could rewrite that saying, if a triangle is equilateral, then it is isosceles. In 10, rewrite the following definition as a biconditional. So I need the if and only if. And the statement reads, a pediatrician is a doctor who treats children. So we could say a doctor is a pediatrician if and only if they treat children. For 11, name 2 activities that rely on good definitions and explain your answers. I just wrote various here because there's so many possibilities that as long as you are justifying your activity with a good reason, I'll most likely accept it as a quality answer. So for example, I'm going to use soccer. An activity that relies on a good definition of soccer because it has multiple rules that all players and participants need to follow. So without clear definitions of the rules, the game would be chaotic. Something like that. And 12, we're looking at parts A and B, and it says, Joan has 3 friends with red hair. All of them are good at math. So Joan conjectures all people with red hair are good at math. Is her conjecture true or false? It would be a false conjecture because we don't know for sure. She hasn't checked every single person on this planet who's ever had red hair to know that they're good at math. So in order for part B, where it says, how would you show that the answer to part A is correct? So how would we support saying that that original conjecture is false? The way we could do that is by providing a counterexample, which would be finding one redhead person who is not good at math. And then the last problem on the second page, 13. If Dwayne mows the lawn, then his dad will give him $10. Dwayne's dad gives him $10. What, if anything, can we conclude? Explain briefly. We cannot mathematically conclude anything because Dwayne's dad could have given him $10 for any reason. Now, if this said Dwayne mowed the lawn, what could we conclude? We could conclude that his dad owes him or has to give him $10. Now in 14, it says, Natalie gets an envelope in the mail with the following advertisement. Receive an extra 15% off your purchase when you open a CloseMart credit account. So write the above advertisement as a conditional statement. If you open a CloseMart credit account, then you will receive an extra 15% off your purchase. Should Natalie expect to receive 15% off her next purchase at CloseMart? Explain. No, she should not automatically expect that because first she needs to open a credit account. 15, A, B, and C, we're dealing with unions and intersections. And we're looking at this figure here. So part A says, the union of ray AB, so starting at A, going toward B forever, and the union of AC, so starting at A, going to C forever. Well, the union of those two rays create an angle. A union of two rays that share an endpoint or vertice is literally the definition of an angle. So what that union creates is angle BAC, or we could write that as CAB. So any points along the segments of that angle or on that angle would be our union. Now AD intersection BC. So where does line AD intersect BC? So AD is across the bottom here. BC is this one. So where do AD and BC intersect? What point is on both? Point C. And then for part C, we're looking at the intersection of ray AC and ray CA. So starting at A, going toward C forever, and then starting at C, going toward A forever. Where do those two rays overlap? They overlap from point A to C. So our answer for the intersection of those two rays would be segment AC. And 16, high school varsity and junior varsity basketball teams are what we're looking at. And we know Jordan and Taylor are the only two players that play on both teams. So Jordan and Taylor are parts of what two sets? They're part of both the varsity player set and the JV player set. So to draw a Venn diagram representing that situation, we would have our circle for varsity, our circle for JV, and in the space where they overlap would be our two players of Jordan and Taylor. In 17, a high school has French, German, and Spanish clubs. Students want to start an international club for the students from all the foreign language clubs. Would the international club represent the union, the intersection, or neither of the foreign language clubs? It would represent the union of those clubs because you simply have to be a member of French, German, or Spanish to be in this international club. And then 18, dealing with our hierarchy. So keep in mind, with a hierarchy, the term you start with at the top is your broadest term, or the most general term. So when we have polygon, triangle, quadrilateral, scalene triangle, equilateral triangle, and isosceles triangle, our most broad term is simply polygon. So starting with the polygon. A polygon can split into these two general shapes that they gave us of a triangle or a quadrilateral. So then I'm left with my three types of triangles. So under triangle, that could split into isosceles triangles or scalene triangles. And then an equilateral triangle is a special type of isosceles. So equilateral would go underneath the isosceles triangle in our hierarchy. So the way we could read this hierarchy would be equilateral triangles are special types of isosceles triangles, which are a special type of triangle, which are a special type of polygon. So the hierarchy starts with the most general or broad term, and then as you work your way down, you are getting more specific or special types.